Hello everyone, welcome to this video on solving logarithmic equations. Now what I want to do is go over a couple of examples of equations that solving logarithmic equations that use properties of logs. In particular, I'm looking at properties that follow, or you can apply rules such as your multiplication property. So if you recall, is log base b of x plus log base b of y can be combined as log base b of x times y. And beyond that, if I have log base b of x equals log base b of y, we can eliminate the logs because they're the same base, and you're left with x equals y. So these are the ones in particular that I'm going to be using to solve these. I'm going to do two examples just to illustrate how the progress that you can make with these. So first, let me give the question we'll use, which is log base 2 of the quantity x plus 1 plus log base 2 of x equals 1. So this is the common way that the common form, that this question will take. Now you see the steps that I've put here. These are three generic steps that we can apply to pretty much any equation like this. First thing is we're going to write the equation with a single log as opposed to what I have here, which I have two logs on one side of the equal sign. And then we'll change form, meaning I'll go from exponential to log form or vice versa. So in this case, we'll go from log to exponential form. And then finally, we'll solve and compare it to the domain. Now, compared to the domain means that we need to identify the domain of this log equation first. And we're going to do that. So I'm actually going to do that first. I'm going to take I'm going to look at two parts. So before I do anything, I'm just going to, and you can do this at the end, but I like to do it at the beginning because it's easier to identify the proper setup, in my opinion. I'm going to look at what I'm taking the log of. I have two things, the x plus 1 and the x. So we're going to recall the general domain of a log function, which is x is greater than 0. So what I'm going to do is, based on these two expressions, underlined in red, I'm going to say x plus 1 is greater than 0, and then x is greater than 0. Sorry, my dog's insisting she be up here. So I have both of these inequalities now. I want to solve each one. Now the second one's done. I can't do much more with this. First one, I'll solve by subtracting 1 from each side, and I'll leave me with x is greater than -1. So these are the two potential domains for this equation. Obviously, we only need one. And so what we do is we pick, one way of looking at it is we pick what will be the most restrictive domain. Because domain has to work for both functions, and so obviously we can't work for just one. So we need to pick a domain such that it would include both individual domains. And so we say, looking at two inequalities here, x is greater than 0, x is greater than -1. Which one of those two is more restrictive, meaning that you have fewer options? And that would be x is greater than 0. Another way of thinking of it is, which of those two numbers, 0 and 1, is bigger? 0, oh, so there's our domain. That's as far as we need to go with that. So when we finish this, we're going to compare our answers to make sure that they fall in this domain of x is greater than 0. Now I'm going to apply from here. I have all my logs on one side, which will help me out. I'm going to apply this rule that I mentioned here, the multiplication rule, And since they're the same, these two logs have the same base, I'm going to write them as 1 log base 2 of x plus 1 times x still equals 1. So I'm applying that rule that I have both parts of what I'm multiplying, both parts of the individual logs I multiply together. So x plus 1 times x. And yes, I can make that log base 2 of, after I distribute, I can make this x squared plus x equals 1. And yes, I feel it's important to keep in parentheses to keep track of things. Now, since I have a single log on the left side of the equation, I'm going to change my form. I'm in log form right now. I'm going to change to exponential form. You recall that means my base 2 to the power 1 equals x squared plus x as so, or just 2, since 2 to the power 1 is just 2. Now solve. So I'm going to subtract 2 from each side. Now I've got over here 0 equals x squared plus x minus 2. Now I'll solve. Now you can, as a quadratic, you can solve by completing the square. You can solve by a quadratic formula, solve by factoring, whatever works best for you. This one looks like it can be solved by factoring, which means I'll make this into x plus. I need a positive 1 and a negative 2, so I'm just going to have to be x plus 2, x minus 1 equals 0. Now, if you recall your zero product property, I can from here say x plus 2 equals 0. So each part say equal to 0. X minus 1 equals 0. Solving each one of them, I'll get x is negative 2 and x equals 1. And remember, I do that because I'll subtract 2 from here to each side, and I'll add 1 to each side here. Let me put that equals 0 back in there. Now, lastly, I want to compare to the domain. So my domain says that x has to be greater than 0. So whatever I choose must be bigger than 0 in order to work. So of my two choices here, obviously I can't choose negative 2. My only answer then is going to be x equals 1. So excuse my phone. Now that I have my solution, x was 1, and now I'm done. So it checks out against the domain, and there's nothing more to do. So as I said, when you compare the domain, you can do it at the very end. I prefer to do the domain first, and then one less thing to do at the very end. So let's try another one. I'm going to say, I'm going to stick to log base 2. I'm going to say log base 2, if I can get my pen to write. Log base 2 of x plus log base 2 of x minus 2 equals 3. Now again, I want both my logs on the same side, so that's already been done. I have addition, so I can write them as a single log. But before I do that, let me look at the domain. I'm looking at what I'm taking the log of. So I'm going to set each of those greater than 0. Now, like before, x is greater than 0 is done. I can't really do much for that. And then x minus 2 is greater than 0. To solve, I'll add 2 to both sides, which will give me x is greater than 2. Again, we said when you determine a domain, which of the two is going to be bigger? The simplest way of thinking of it, and that's going to be x is greater than 2. So that becomes my new domain. Now that I have that, I'll combine these since there's addition and they have the same base. That's our multiplication property for logs. So I have a single log base 2 of x times x minus 2, still equal to 3. And keep in mind, it's not log of x times log of x minus 2, it's just x times x minus 2. And I'll write that as x squared minus 2x. Now I have a single log, I'll change form. And also this works because I have a constant on the other side, so I can change my form. 2 to the power of 3 equals x squared minus 2x. Of course, this becomes 8. And I'm going to solve both sides. I'm going to subtract 8 from both sides, leave me with 0 equals x squared minus 2x minus 8. And like 4, I want to solve my equation. And keep in mind, since I have a quadratic, you can solve however you want. In general, because I know some people might not always think to bring 8 to the right, you could have brought x squared and 2x to the other side. You just have more negatives to deal with. The general rule that I go by, if you're ever confused, is which side would my biggest exponent, excuse me, in this case the x squared, be positive on? And since it's already positive on the right, I'm going to bring everything over there, just because that's usually simpler. So this one can be factored, it looks like. Something that can multiply to a negative 8 combined to a negative 2 tells me negative 4 and positive 2. And my property says I'll set each one of these equal to 0. So I'll solve by adding 4, subtracting 2. My two solutions, at least my potential solutions, are x equals 4 and x equals a negative 2. So in other words, algebraically, they both work, but we want to make sure they work in the context of our domain, which is x has to be greater than 2. So that leaves us only one choice and let me try to be consistent. Signify we have our answer, x is equal to 4. So with these, remember our 3 steps. Get all your logs on one side. Apply the appropriate property of log. In these examples, this is the multiplication property. Change your form, in this case from log to exponential, and then solve and compare to the domain. Hope this helps you in your math journeys, and have a good day.